Hello, and welcome to Electrify Everything, the what, why, and how of home electrification. This presentation is by Electrify Everything Minnesota, which is supported by the cities of Edina, St. Louis Park, Eden Prairie, and Minneapolis, and implemented by the Center for Energy and Environment. Today, we'll start by talking about what is electrification. Then we'll dive into the different high priority categories for electrification, which are weatherization, heating, and appliances. Then we'll talk about how to get electrification ready, motivations for electrifying, and we'll wrap up with our website and some resources. So what is electrification? Electrification is replacing fossil gas or natural gas equipment and appliances with electrically powered options. The Electrify Everything program, supported by St. Louis Park, Edina, Eden Prairie, and Minneapolis, aims to support the gradual electrification of single-family homes to promote resident health and climate sustainability. Now we'll talk a little bit about why electrify. So there are growing options to use clean electricity in your home. The electric grid is getting cleaner as coal generation is retired and renewables are scaled up. Using electricity is also safer. Electric appliances remove the common hazards of gas equipment in your home, like indoor air pollution and combustion hazards that can cause different respiratory illnesses and also be a pretty big safety risk. Electricity rates are also more stable than natural gas rates. Electricity rates historically grow at an incremental pace because they are regulated here in Minnesota by the Public Utilities Commission, so the changes are more incremental, while fossil fuel prices are more volatile because they're purchased on the open market. A big example of this was when there was the big storm in Texas a few winters ago and natural gas prices spiked across the country. Electrifying our homes also makes a difference for the health of people and the planet. We can all take part in climate action by transitioning our home equipment to electricity from gas. This is a really tangible step for your family to fight climate change through the improvements to your home. So electrification is really exciting in principle, but the challenge is that it can be very confusing. What exactly goes into electrifying a home? So there are many questions that homeowners encounter when considering how to electrify their home. How do I decide which projects to pursue? What are the equipment options and how do they compare to each other? What resources and incentives are available to help with the cost? And who do I talk to for guidance and bids? What can I do DIY or myself? These are all really common questions and more that you'll encounter along your electrification journey, and we'll dive into the answers in this presentation. The key projects for electrifying a single-family home are weatherization, heating, water heating, clothes drying, and cooking. These are all really important pieces. They're the largest energy users in your home and the best way to save energy and switch from fossil gas to electricity. Throughout the presentation today, we'll have some trivia questions to help test your knowledge on electrification. So as I read the answers, or read the options, think of the answer in your mind, and then we'll reveal the answer. So just as a practice, which are seasons in Minnesota? You can choose multiple. So winter, spring, construction, or fall. The answer is winter, spring, fall, though some may argue construction season is definitely a season here in Minnesota. So we'll start by diving in to weatherization. So what is included in weatherization? Choose multiple. Air sealing, furnace, windows, or insulation. The answer is air sealing, windows, and insulation, and we'll explain why. Weatherization involves improving the parts of the home that keep heated or cooled air from escaping. So that's insulation, air sealing, and windows. Weatherization makes electrification easier and more effective. Insulation keeps the heat you put in your home inside in the winter. Air sealing prevents that heat from escaping through cracks and leaks in your home. And windows, if they are old or leaky, can be sealed up or replaced to prevent heat and air loss. So insulation. What parts of a home typically lack insulation? The refrigerator, the walls, the windows, or the attic? The answer is the walls and attic are the most common places where insulation is lacking. The reason for this is that most homes built before 1980 often lack wall and attic insulation. Insulation and air sealing saves 18% in heating and cooling costs in the average Minnesota home. That's a huge reduction in your energy bill every month. It's also cost effective. It'll pay for itself over time as you reap the benefits on your lower energy bills after doing insulation and air sealing work. It also improves comfort. Those drafty rooms will be more airtight and well insulated. It's like putting a big blanket and windbreaker on your home to keep all the heat in or the cool in the summertime. Insulation and air sealing prevent ice dams. Ice dams are those big icicles we see hanging off our roofs in the wintertime. Those are caused by heated air escaping from the home, heating up the roof deck, melting the snow, and then causing freezing at the eaves, and then causing that buildup. And the big piece is that weatherization, or insulation and air sealing, sets up a home for electrification. When we can keep the cooled and heated air that we put into our homes inside our homes, the other equipment, like a heating system, need to work less hard. Air sealing is a really important piece of insulation work that is often overlooked. So air sealing prevents conditioned air from escaping and outdoor air from entering. Common air leaks include attic hatches, lighting that penetrates through the ceiling into the attic, vents and chimneys like your plumbing stack, bath fan vents, chimney stacks, and then rim joists in the basement, kind of that where the wall of the basement meets the ceiling of the basement is a really common place for cold air to enter the home. And so you can put a bunch of cellulose or fiberglass insulation in your attic and your walls, but those are not actually air barriers. So they're keeping the heat from transferring into the attic, but heated air can still escape through air leaks. So sealing up all those air leaks with caulking, spray foam, and other methods is really important. Here is an infrared image of an attic. You can see on the left here, we've got a wall, a window, and then the ceiling. And on the right, all the purple spots are where cold air, or where air leaks are happening. So that's cold. And we can see where the wall meets the ceiling, there's a lot of air leakage happening. The attic hatch is super leaky, and we also see some air leakage around the wall. So you can imagine in a whole house, there's a ton of little air leaks if they haven't been treated, and these can really add up to quite a bit of air escaping from your home. So all the air leaks in an old home can add up to having a what size hole open at all times? 1 square inch, 6 square inches, 12 square inches, or a 24 square inch hole in your home? The answer is a 24 square inch hole. So air leaks in a typical older home that has never been air sealed can add up to having a roughly 2 square foot hole in your home. That's like having a window open all winter long. That's a lot of cold air getting in and heated air escaping. Another question, why is weatherization important for electrifying heating? A, it reduces energy usage. B, it helps heating systems work more efficiently. C, it minimizes heat loss. And D, it keeps away bad weather. The answers are A, B, and C. Again, keeping that conditioned air inside your home to use less energy and help your heating system work more efficiently and put less strain on it. So weatherization is critical before addressing heating. Weatherization makes electrifying your home's heating much more affordable and effective. We'll dive into this in a little bit, but weatherization reduces heating load on average by 18%. So that's 18% less energy and heat you need to put in your home because it's not escaping once you've done insulation and air sealing. A quick technical term, load, or heating load, is the same as heating need. So the heating load is the amount of heat energy that would need to be added to a space to maintain the temperature in an acceptable range. The cooling load is the amount of heat energy that would need to be removed from a space, cooling, to maintain the temperature in an acceptable range. So when we say load, that's how much heating or cooling is required by your home to keep it comfortable. Now we'll move from weatherization to heating. So weatherization and heating equipment both address the main use of energy in Minnesota homes, which is heating. It's hard to understate how important this is here in our very cold climate in Minnesota, because 70% of the energy we use in our homes goes to heating for the year average. This is way higher than the national average, where 40% of all of a home's energy use go towards heating. So when we are looking at ways to reduce energy use and electrify our energy use, switch from fossil fuels to electric, heating is the highest impact option. So weatherization helps reduce the heating load required, so it makes that 70% go down, and then heating equipment, electric heating equipment, can help electrify that heating load. So weatherizing before adding electric heating makes the switch easier and more affordable. This graph shows two homes. The orange one is a drafty home with poor insulation that needs more heat to keep comfortable. And the blue home is a weatherized home that needs less heat to stay comfortable. So we see on the left axis here, this is the heating load required, and then the outdoor temperature. So we see at 5 degrees, for example, the orange house that's unweatherized requires a lot more heating load capacity than the non-weatherized one to stay comfortable. So this is where heat pumps come in. Heat pumps are a great option for efficiently electrifying your heating load. And so now we're going to dive into these. So true or false? A heat pump can heat and cool your home. The answer is true. Heat pumps both heat and cool a home. So why are we talking about heat pumps? Well, because electrifying your heating will likely involve a heat pump. Heat pump technology provides cooling and heating to a home. It's highly energy efficient. It works by moving heat, and it's essentially an air conditioner that can run in reverse. These graphics illustrate how heat pumps provide cooling in the summertime and heating in the wintertime. In the summertime, heat pumps work the same way that air conditioners do by moving heat from inside your home to outside your home. They're basically extracting heat inside and moving it outside to keep it cooler inside your home. This is the same way your air conditioner works. Also, this is the same technology your refrigerator uses. In the wintertime, to heat, heat pump moves heat from the outside to the inside. So it extracts heat from the air outside, even in very low temperatures, and moves it to the inside. By transferring heat instead of creating it, like by burning gas or heating up metal like electric resistance heaters, it's way more efficient even at cold temperatures outside. So how much more efficient can a heat pump be than electric resistance heating? A, the same. B, 1.5 times more efficient. C, 3 times more efficient. And D, 2 times more efficient. And this is a heat pump and an electric resistance heater, which creates heat just by heating up electric or metal elements with electricity. The answer is C, 3 times more efficient. The electric resistance technically converts 100% of the electricity used into heat by putting all of that electrical energy into the metal elements that then heat the room. However, air source heat pumps, because they are moving heat from the outside to the inside, are technically can be up to 400% efficient. So the electrical energy that they require can create 4 times that amount of heat by transferring it into the house. Pretty cool. So heat pumps are most efficient in hot to cool weather. So colder weather lowers heat pumps' efficiency. Makes sense. The colder it gets outside, the less heat there is to extract from the air and move into the house. So this is a graph showing the outdoor temperature on the bottom and the heating provided by a heat pump on the top. So we see that at 65 degrees, it can provide a lot of heat. And then when we get down to negative 15 Fahrenheit, it's lower. Another reason why weatherization is so important is that you can use a heat pump for more of the winter with proper home weatherization. So an unweatherized home that's poorly insulated and drafty can heat with a heat pump down to roughly 20 degrees Fahrenheit. And when the outside temperature is below that, the backup heating system, whether that's a furnace, boiler, or electric resistance, would kick in. That same home, if it's fully weatherized, that same heat pump could provide all the heating that home needs down to 5 degrees Fahrenheit or even below that. So before the backup system needs to kick in. So by weatherizing, we greatly expand the capacity of the heat pump to provide most of the heating that this home requires. Building on that same example, this is the home that is not well weatherized, and we can see that the heat pump, if the heat pump runs to an outside temperature of 25 degrees, it'll cover about 72% of the heating hours for the year. What that means is over the whole winter, we calculate how many hours require heating, and we could see that the heat pump would cover 3/4 of those, and then the backup system would cover those colder days. Even though those really cold days in the Minnesota winters really stand out in our mind, they make up a relatively small number of hours. So we still have pretty good coverage with the heat pump here. However, if that same home is weatherized, the heat pump can cover 95% of the heating hours of the winter when it's running down to 5 degrees Fahrenheit outside temperature. So yeah, we see that those really cold days where it gets below zero and well below zero, those are good days for a backup system to kick in, but they make up a really, 5% of the winter, and the rest of the time the heat pump could be providing all of your heating with carbon-free electricity. So now that we've talked about how weatherization and air source heat pumps go hand in hand, we can talk about different heat pump setups. So heat pumps can either partially or fully electrify your heating needs. And your choice of secondary heating source determines whether it is a partially or fully electric system. So partial or dual fuel is a system where your heating switches between the heat pump and the furnace or boiler depending on the outdoor air temperature. A fully electric system would mean your heating is provided by your heat pump alone with a booster electric resistance heating for those really, really cold days that get well below zero. So dual fuel would look like this. In the summertime, the heat pump provides cooling. In the fall, the heat pump provides heating. In the winter, when it gets below 20 degrees, you could set it so that the furnace heats your home. And then in the spring, again, the heat pump will kick in when it's more mild. So what are the benefits of a dual fuel heating system? A, fuel flexibility to keep bills low. B, cooks your food. C, efficient heating and cooling. And D, zero emissions potential. The answer is A, fuel flexibility, and C, efficient heating. That fuel flexibility to keep bills low is a big one. With a dual fuel system, you can choose the point at which your heat pump switches over to the backup system. You can optimize that for costs, so you could switch over when natural gas is cheaper to use for heating than electricity based on your heat pump's efficiency, or you can do it based on your heat pump's capacity, where you switch over when the heat pump can no longer provide the full heating that your home requires because of the low outdoor temperature. So it provides a lot of flexibility and control. And it's also a really highly efficient way to heat and cool your home compared to the other options. So a fully electric heating system would include a heat pump system with electric resistance secondary heating. Gas heating is completely removed in this scenario, and it maximizes emissions reductions. And the way it works is that the heat pump would provide all the cooling and heating all year, and then the system would automatically turn on the electric resistance heaters for extra heat as needed in those sub-zero days when the heat pump needs a little help to meet your home's heating needs. This would look like in the summer, heat pump provides cooling. In the fall, the heat pump provides all the heating. In the winter, the heat pump provides heating, and then the electric secondary kicks in when it's needed. And then in the spring again, the heat pump provides all the heating. So what are the benefits of a fully electric heat pump system? A, it doubles as a security system. B, efficient heating and cooling. C, lowest winter heating bills. Or D, zero carbon potential. The answers are B, efficient heating and cooling, and D, zero carbon potential. And we'll explain why on the next slide. What are the pros and cons of a fully electric heating system? So the pros are zero carbon emissions potential. This is one of the answers in our previous trivia question. By having a fully electric heating system, a renewable energy subscription or solar panels on your roof can make your heating system zero carbon now, immediately, before the grid reaches carbon neutral in 2040 here in Minnesota. So this is a really big impact for climate. That said, the electric grid in Minnesota is clean enough, has enough green energy on it, that using an electric system has fewer emissions than a gas system, even without extra renewable energy subscriptions. Another pro is that a fully electric heat pump system is very efficient for heating and cooling. A con is that secondary resistance heat is expensive. It's more expensive than a natural gas backup. So bills may be higher than a fossil fuel system on the coldest days here in Minnesota. Those days are relatively few each winter, but the fully electric system does lack that option to optimize whether you use electric or natural gas based on cost efficiency. So that's the one con here. And with that wraps up our heating section. The next area of electrification we're going to talk about are our appliances. So the biggest opportunities to electrify your appliances are with water heaters, using a heat pump hybrid water heater, cooking ranges, that's stovetop and oven, upgrading to an induction range or a traditional electric range, and then clothes dryers, either a heat pump ventless clothes dryer or a traditional electric clothes dryer. So we'll start with water heating. Of our appliances, besides the heating system, water heaters typically use the most energy, and hybrid heat pump water heaters are very energy efficient. So it's an energy efficient way to electrify your domestic hot water. They're safer than gas because they don't have any combustion systems in them. They can't leak dangerous gases into your home. And they are more efficient than electric resistance, making them cheaper to operate. We'll start with water heaters. So hybrid heat pump water heaters use the same technology as an air source heat pump or refrigerator. They move heat from the surrounding air into the water through coils to heat the water. They also have electric resistance elements that just use electricity to heat up metal to help to add additional heating capacity when necessary to reach temp. When the heat pump pulls in air from the surrounding area, it'll blow out cooler air because it has transferred the heat into the water. And the combination of heat pump and electric resistance enable heat pump water heaters to provide hot water as frequent and fast as other water heaters, which is great. So to compare hybrid heat pump water heaters to traditional electric resistance water heaters, the first is that hybrid heat pump water heaters have the heat pump and the heating element, while electric resistance has the heating element only. Heat pump water heaters are much more energy efficient than electric resistance, which makes them much lower have a much lower operating cost than electric resistance. Some additional differences are that heat pump water heaters will dehumidify the air a little bit because of the condensers that they use. They exhaust some cool air into the basement or the area where the water heater is, and they make some noise when running. There's a fan running, pretty similar to a power vented gas water heater if you have one of those in your home. Electric resistance water heaters do not have any of those features and make pretty much no noise when operating. So, a heat pump water heater uses how much less energy than an electric resistance water heater? 10%, 33%, 50%, or 66%? The answer is 66%. So they use a lot less energy and cost a lot less to operate than traditional electric water heaters. As a comparison for savings, a standard electric water heater to a hybrid heat pump water heater will save about $300 to $500 annually on electricity costs, which will make the payback for upgrading to a heat pump water heater pretty fast. A switch from a standard gas water heater to a hybrid water heater will have savings anywhere from breaking even to $175 annual savings. So this is a big win for the climate and can also lead to dollar savings on your bills each year. These guides on the right here just show two example water heaters. A traditional electric might cost $419 a year to operate, while a heat pump water heater would cost just $114 a year. So a pretty big difference. Now we'll look at induction ranges. So induction ranges transfer energy directly to the cooking pan through a magnetic field. So instead of heating up a metal element like traditional electric or lighting gas on fire like a gas range, they use electromagnetic waves to heat up the pan itself rather than the surface. Water boils in less than half the time on an induction range, so they have really great control and speed of cooking. And the cooktop surface is safer. It doesn't get as hot, and cleaning is super easy with these stoves. So thinking about induction ranges, how fast can an induction range boil a quart of water? 2 minutes, 4 minutes, 8 minutes, or 12 minutes? The answer is 2 minutes. Gas and traditional electric ranges typically take 7 to 12 minutes to boil water, so way, way faster on an induction range. That said, for cooking, a traditional electric range is also a really great option for electrification. They create heat by running a current through a heating element. They're widely available and very affordable, so they can be great for a quick replacement option. They're a little less energy efficient than induction ranges, and they're slower to warm up and cool down, and harder to clean. But as far as the total energy use of your home compared to an induction range, you'd save a little bit, but not a lot. And these can be a more easier entry-level option for folks looking to electrify their cooking. So which pots work with an induction stove? This is a question we get a lot. A, cast iron, B, steel, C, aluminum, or D, copper. The answer is A, cast iron, and B, steel. So ceramic cookware with an iron core also works on an induction stove. Anything that is magnetic. So an easy test is take one of your pots and pans, stick a magnet on the bottom. If it sticks, it should be induction compatible. Most people think they'll have to completely replace all their cookware if they upgrade to induction, and this usually is not the case. A big reason to switch from fossil gas cooking to electric cooking is safety and indoor air pollution reduction. Gas stoves release several hazardous pollutants into the living space, such as nitrogen dioxide and carbon monoxide. Electrifying your cooking removes these pollutants from your home completely. A study by the International Journal of Epidemiology found that children living in households with gas ranges are over 40% more likely to have asthma. Gas ranges also may leak dangerous pollutants into the home even when they're turned off. So they just can be a big health risk that can be avoided through electrifying your cooking. All right, now let's talk about dryers. So what are heat pump clothes dryers? They're also called ventless dryers, and they use warm air to transfer moisture out of the clothes into a drain pipe. They're more energy efficient and gentler on clothes than traditional dryers, but they do have longer drying cycles than traditional dryers. They do not need to be vented to the outside, which is a really big advantage, so they can be placed anywhere in the living space where a plug is accessible. So a heat pump dryer uses how much less energy than an electric resistance dryer? A, 10%, B, 20%, C, 50%, or D, 200%. The answer is 50% less energy. While they use more electricity than heat pump dryers, electric resistance dryers are a great electrification option if you have a gas dryer already. The electric resistance dryers use heat from electric coils rather than combusting gas to dry the clothes. They're widely available, affordable, and they dry clothes very quickly. Compared to heat pump dryers, they use about twice as much energy, and they also need to be vented to the outside. So those are the two kind of trade-offs, but they're, again, a really great option for electrifying at an entry-level point. And that wraps up our appliance section. So now we'll talk about your home and how to get your home ready for electrification. Some homes will need pre-work before electrifying. Common upgrades needed by older homes include upgraded electric service panel and modern wiring. Believe it or not, homes built in the 1900s were not built necessarily ready for heat pumps and heat pump dryers and all this. So it's possible that you may need to upgrade your electric panel to have more capacity to install these new electric appliances. And some homes with old wiring, such as knob and tube wiring, may need to upgrade for safety and to be able to install these new technologies. These projects will make it possible to add electric equipment later. A common upgrade is from a 100 amp to a 200 amp service panel, and consulting an electrician regarding the needs for your home is the best place to start. Our energy advisors can also give you a hand here, and we'll talk about them in a second. Beyond pre-electrification work, a really great place to start is a visit with the Home Energy Squad. So the Home Energy Squad is a low-cost utility program, and they will come to your home, conduct an energy audit where they will look at your heating system, so you'll find out what systems you have, what equipment your home has, and how old it is. They will assess the weatherization, so the insulation, air sealing, and windows to determine if your home could benefit from more weatherization. And then they will connect you with recommended contractors and incentives afterwards. So this is a really great place to start if you aren't sure exactly where your home is and if you want help prioritizing which electrification projects to start with. Another great resource is calling our energy advisors. So residents of Edina, St. Louis Park, and Eden Prairie can call the energy advisors with any question related to electrification. It's a cost-free, pressure-free service, and our energy advisors will help you walk you through the steps of completing home projects, whether that's which contractors to get bids from, evaluating quotes to decide which quote to move forward with, and also they'll help you navigate financing, utility rebates, and other financial incentives that are available. So they're a really great place to call if you have questions about completing projects. Another great resource are the Citizens Utility Board's free energy bill consultations. During the consultations, CUB staff will talk about opportunities to make your home more energy efficient, steps towards electrifying your home, financial incentives at the federal and local level, and any energy-related concerns. So this is a great place to go for financial questions and bill analysis to get you started. So in summary, the resources available to help you get started are to schedule a Home Energy Squad visit to learn more about your home, contact an energy advisor for expert advice and contractor connections, and then contact the Citizens Utility Board for financial questions. These are all really, really great places to start, and they are available to you. Now for our last section of this presentation, we'll talk about how to prioritize projects based on your motivations and goals with electrifying your home. We have 3 pathways that we've identified. So one is the Climate Now pathway. The Climate Now pathway features the highest impact projects first to cut greenhouse gas emissions the quickest. So the first project here would be weatherizing your home. Weatherizing is the most cost-effective way to reduce your home's carbon emissions and save money on your energy bills. And then step 2 would be adding an air source heat pump for heating and cooling. But with these 2 options, you will cut your home's carbon emissions by the biggest chunk, again, because 70% of the energy used in the typical Minnesota home goes towards space heating. The next pathway is the easing in pathway. Easing in starts with lower cost, easier to install appliance upgrades for families that maybe aren't ready to make such a big financial commitment right out of the gate. The first project would be switching to a heat pump clothes dryer from a gas dryer. This will have health benefits and also cost savings. And then number 2 would be switching to an electric cooking range from a gas range. The third pathway prioritizes a healthy and safe home. So healthy and safe home starts by improving your home's air quality by tackling the most direct sources of pollutants in your home. The first project here would be switching to an electric cooking range from a gas range. eliminating those indoor air pollutants in your living space. The second would be to switch to a heat pump water heater. Natural gas, naturally venting water heaters can leak a lot of dangerous pollutants into the home, so this is a great opportunity to tackle. Second, improve that indoor air quality and be more energy efficient. So between the three pathways, Climate Now, Easing In, Healthy and Safe Home, we hope that can help you prioritize based on your motivations and decide which electrification project to do first. Most folks aren't electrifying their entire home all at once. It's usually a process over many years, and getting started now just with one project is a great way to start. To get started, we recommend visiting our website at electrifyeverythingmn.org. Our website is really a wealth of information to help you complete these home projects, with information on upfront and operational cost ranges for equipment so you know what to expect, details of technology options, notes on installation concerns and considerations, links to resources and additional information, such as our preferred contractor network to help connect you with contractors to get started. Also, financial incentives and rebates from the federal government, state government, local governments, and utilities. We have just a ton of information on this website, and you'll also be able to find information on our resources like the Home Energy Squad, Energy Advisors, Citizens Utility Board. So head there and please reach out to us with any questions. Our email is info@electrifyeverythingmn.org. And you can follow us on social media as well. So thank you so much for attending this introductory presentation on home electrification. We hope it was useful, and we look forward to hearing from you with your questions and your journey to electrify your home. Thanks so much. Bye.